So hello everybody, welcome to today's XIFI webinar in which I will present the FIWARE Lab Solution for managing resources, services and services in a federation of cloud infrastructures. So my name is Yahya Al-Hasmi. I'm working as a Senior Research Fellow at the Technical University Berlin. So the webinar will take 1 hour, including discussion at the end. So I cannot move. So the agenda of this webinar includes an introduction to the topic. I will then introduce the FIWARE Lab that represents the Cloud Federation built by the XIFI project. Of course, its federation architecture will be discussed, but in a high-level overview shortly, as only some of its components are of our concern in this webinar. The FIWARE Lab Cloud Federation Management, or the solution, the management solution from the application developer's viewpoint, will be discussed in more details. The webinar will end then with a short conclusion. Then we will have a couple of minutes for discussion. So I think we all are aware of the fact that open innovation is one of the active trends during last years. So the question, what do we mean with open innovation here in this stage? So for us, open innovation is about the creation and profit from available emerging technologies by providing open ecosystems, or also called platforms, that encourage the easy and open exchange of ideas to produce innovative products, solutions, applications, and so on. So obviously, cloud services and capacity are of great value to support open innovation, and of course facilitate startup incubation through infrastructure resources, so that startup developers or owners can get whatever resources they need in an easy and flexible way. So well, it sounds great, which leads to more hopes and expectations. I mean, the great success of the cloud computing brings some hopes and expectations more than what we had in the past. So, but what if we ask just one question in this stage: how to create a large distributed cloud to post innovation across European regions? So I meant to have a large scaled environment for innovation. So we will see, or we will have two alternatives: either through large investments by a single player, or through an agreement among multiple players. The second case, we refer to this with a federation. So we integrate multiple players, or like, let's say, cloud providers, all together in one agreement, and then offer just one single environment. So of course, integration of different players, which means team up together within a federation, is not a trivial task. They don't want to lose all the control on their own environment or infrastructure. For instance, an infrastructure owner may not want to share all its monitoring data, or may prefer to use a particular solution to provide network connectivity for the users, allowing them to access to the environment, or may request the user to be registered in advance through a local identity management solution, of course, which is different than the one provided by the federation. So, I mean, there are several challenges and motivations behind cloud federation. There is many solutions, architectures in the literature, and as well there is different federation models, approaches. So, but of course there is no one best cloud federation approach. They have of course, different approaches, different models, and they each has its own pros and cons, and of course are built depending on different requirements for different usage. So our focus in FIWARE Federation, which is conducted of course by the XIFI project, is to build federation of cloud infrastructures for future internet experimentation and research, for open innovation, for the developments from startups, SMEs, etc. So this is offered through the FIWARE Lab. So what's FIWARE Lab? FIWARE Lab is an open innovation platform for future internet applications development. It offers, the FIWARE Lab offers a rich catalog of services and technologies that are available either in software as a service or platform as a service models. These are called in FIWARE Lab or in FIWARE terminology as generic enabler implementations. FIWARE generic enabler implementations are a set of general purpose platform functions and services available through open APIs. So in addition to the generic enablers, the FIWARE Lab provides a wide range of future internet facilities such as sensing capabilities, 4G networks, software-defined networking capabilities, OpenFlow, etc. So in order to advance the market with smart infrastructures, allowing advanced experimentations, of course for developers, allowing them to create innovative applications or services and link these with actual infrastructures and test environments in a real-world controllable environment. So again, FIWARE Lab is seen as community cloud for European future internet public-private partnership developers or for future internet developers, which is enabled by advanced infrastructures across Europe. So what's the relationship between FIWARE Lab and XIFI? XIFI, which is a part of the overall vision of the FI-PPP, built the FIWARE Lab Federation following, I like this statement, following the principles, eat your own dog food. Of course, this federation is based on FI-PPP technologies that delivered by FIWARE project. So again, FIWARE Lab is the correct environment or the meeting point where innovation takes place. So we'll see diverse stakeholders that can be part of FIWARE Lab, including, let's say, infrastructure owners, technical or technology providers, entrepreneurs, developers, application customers, data providers, etc. So all these stakeholders interact in one environment, large-scale environment distributed across Europe. So technology providers can provide their services, technologies before they are put in the market. Application developers can use them, they can provide their feedback, and of course technology providers can provide GEs, let's say generic enablers, or another terminology which is used, we refer to other technologies with specific enablers in a particular domains, let's say in IoT domains, in e-health domains, etc. So as I said, it's healthy or innovative environment for multiple stakeholders. And as you, I think, are aware of the fact that in the second phase of this program, it's around 100 million euros are provided for funding SMEs, startups who can apply through open calls to be part of the FIWARE Lab ecosystem. So, of course, large number of SMEs, I think around 80, have got or accepted and have got fund for doing the experimentation. So the FIWARE Lab includes, of course, several nodes. This slide shows the current FIWARE Lab deployment across Europe that includes 17 distributed cloud-based infrastructures. We refer to an infrastructure as a node in FIWARE Lab. Of course, the green nodes represent the initial nodes that build the federation. There were 5 nodes, while the orange nodes are the additional 12 nodes joined the federation in the second phase of the program. All together are around 17. All these nodes are interconnected based on a layer 3 multi-domain virtual private network provided by Gion. Each node should include cloud hosting capabilities in order to provide the cloud, traditional cloud services, or at least support these, and offering a set of generic enablers or FIWARE services. Generic enablers, it's the same. In addition to these, some nodes offer diverse set of future internet facilities, advancing the market, as I said, with the smart infrastructures or capabilities. If you see in this screenshot, this figure, nodes include different capabilities through different icons, as you see on the left side, wireless access and cloud capabilities, energy measures, sensor capabilities, etc. So nodes have different, of course, capacities, and all together offer over 3,000 computing cores with 16 terabyte of RAM and 750 terabyte of storage capacity. So in this slide, we see the federation topology or the federation deployment. Of course, we just have here 5 interconnect nodes for simplicity. However, not all links are shown between these nodes. FIWARE federation architecture distinguishes between 2 types of nodes. We have master node and we have slave node. The master node includes the management and operation layers, while the slave node includes only the operation layer. So we see that in the master nodes we have both the federation management solutions and the operations. Operations means things that or the components and software required for deployment of services and resources. We will discuss this later. So this slide shows the FIWARE Lab Federation architecture. As you see, it includes many components. It's a little bit complicated and it's not clear in this. I cannot show a bigger architecture, but it's somehow out of the scope of this talk. We will not discuss the entire architecture. In this architecture, we see that the upper part represents the management layer of a master node, where the centralized parts of the federation services are deployed. That means the software components needed for supporting federation management and the provisioning of resources and services across the federation in a unified fashion. So while the lower part represents the operation layer, that of course exists in both. That means that, as I said before, operation layer exists in master nodes and slave nodes. To be noticed here that we don't have only one central master node, but we could deploy 2 or 3 or 4 master nodes. These nodes include, of course, as well the lower part of the architecture, the operation layer, which comprises 3 main functional groups which enable cloud hosting, which is based on OpenStack, monitoring and security functionalities. I mean, all these components in the lower part, they represent 3 main subsystems: cloud hosting, monitoring, and security functionalities. So installation of this software is mandatory to be in each node willing to become part of the FIWARE Lab Federation, I mean the lower part. But the upper part exists only in the master nodes. So before I jump to this, I just check if there is any. So I continue. So in this webinar, we will not discuss all components of the federation architecture, as I said, but only those innovative ones that are working in an orchestrated manner in order to perform core operations dealing with the management of resources and services across the federation, of course, which means the management, federation management from developers' perspective. So generally speaking, there is a need for a couple of components dealing with different aspects. We discuss here only 3 main requirements. So the first one, a developer must be capable to deploy multi-tier applications. Of course, given that due to some regulatory or security reasons, each team may need to be deployed in different infrastructures. And developers must be able to select among a set of configuration tools that will be or will help him to minimize the operations, such as upgrade, etc. So we can say that there's a need or ability to deploy multi-tier applications across the federation. Now, this is the first one. The second requirement is an application developer should have the ability or opportunity to check the available GEs or already available in the cloud federation. Which are the GEs, which are the services, in order to be able to combine them and develop complex applications timely and easily. So how to know this or to conclude this, there's a need for having real-time information about these services. So we can offer these through RESTful APIs so that developers can check and send queries to ask for such kind of knowledge. The third requirement is that the application developer should have the ability to monitor the performance of the federated resources or the resources across the federation. Of course, that belongs to him, or even information about the physical machine hosting their virtual instances, information about the networking resources, etc. So, but how to collect data from distributed domains that could have different solutions or monitoring solutions? We need to handle this in a way, in a standardized way, in a unified manner, allowing large-scale monitoring data gathered, stored, and aggregated and published in a well-defined, standardized API, as much as possible. So in this slide, we see a simplified architecture, simplified in a sense that, as I have shown, the entire federation architecture, it includes many components. However, in this architecture, or in this figure, we show just the three main components that are in charge of fulfilling these requirements presented before, namely the deployment and configuration component, which is in the master node, the Pegasus that represents the platform as a service component, and the federation monitoring component, which is distributed in all nodes. That means in the slave and the master nodes. The interactions of these three main components with the remaining components of the FIWARE Lab Federation architecture are illustrated. However, the dotted components and their interactions represented in dotted lines are out of the scope in this webinar. But of course, due to the interactions between the main components of this talk, they are represented. So, how the entire story works from the application developer's viewpoint: to access the cloud resources, the developer offers, or after authenticating through an IDM managers, which is based on auth, it can log into the FIWARE Lab Cloud portal that enables the user to see the list of available resources and services according to their locations, of course, in which side, in which node. And retrieve on-demand information regarding the provided services already deployed and used by other users via the resource catalog. That means the resource catalog can show the available and the running GEs, and there is recommendation tools for users to use which GEs could be used for what reason. The user which willing to deploy his own application may select one or more services or GEs that are stored in the generic enabler repository, either through pre-built images or provided through the or in a dynamic composed recipes provided through the Pegasus. Pegasus offers the ability for the developers to deploy multi-tier application where each tier is deployed in different slave node. So it communicates with the data center resource manager, DCRM GE, in each node, which represent the cloud infrastructure as a service manager, and deploys the requisite appliance either through a single virtual machine, a single GE, or multiple GEs, etc. Once the deployment are achieved, of course, a deployment of an application could be deployed across multiple nodes. Once the deployment is finished, two activities take place. The first one, that real-time information are gathered regarding the new deployed instances or GEs. This information is collected or being provided through the DCA, Deployment and Configuration Adapter, which is in the upper part of this architecture, the master node. The second activity is the collection of monitoring information about the instances, the physical and the virtual resources, the network connectivity, etc., about CPU load, memory, etc., which is provided via the IMM component. IMM represents the infrastructure monitoring middleware that collects through multiple adapters information and provide them in a common way to the federation monitoring component. So now discussing the three main components, namely the Pegasus, go back, deployment and configuration, and the federation monitoring. Starting with Pegasus platform as a service implementation. Pegasus orchestrates the provisioning of the required virtual resources at different infrastructure level, responsible for installation and configuration of the whole software stack of an application. It enables a user to deploy easily and any kind of application, be a single virtual machine, a single GE, or multiple GEs, or multiple virtual machines. So it depends on the scenarios. Of course, allows users to deploy multi-tier applications where each tier can be accommodated by a different infrastructure or different node in a federation. So, as we all know that the manual deployment is time consuming and we cannot have or repeat the operations or the deployments, because we should redo all these kind of deployment, configuration, instantiation, etc. However, the Pegasus facilitates the creation of applications, reducing the complexity and the costs of provisioning for the required resources and their management, etc. So the Pegasus configures the virtual machines deployed in order to allow the monitoring of the resources, identify the GEs deployed on these virtual machines, this kind of identification to have a unique identifiers across the federation, identifier of each deployed generic enabler. We might have, for instance, the same instance of a generic enabler deployed in different nodes, maybe by the same developer or by multiple ones, in order to have unique identifiers. This is one of the jobs of the Pegasus. The deployment is achieved through the so-called infrastructure template. The developers provide so-called infrastructure template of his application and then pass to the Pegasus that is in charge of doing the entire installation and configuration. Of course, this allows or facilitates reusage of these templates. It can be reused each time a developer needs to deliver a new instance of the application. And whenever changes happen, the developer can just update the template and pass it to the Pegasus that will do the job. Pegasus is responsible for preparing the images to connect automatically, for instance, with the federation solution to, in order, of course, when I as a developer, when I request X, let's say 10 generic enablers might be deployed on 3 or 4 or 10 virtual machines, I need to know some information about these machines. So there is two possibilities to configure these resources to deliver monitor information. The first one, either to have pre-configured clients already installed in all the available images provided by the FIWARE Lab Federation. Imagine we have 17 infrastructures. Each could provide up to 30, 40, 50 different images and different operating systems. I don't know how many are there, but this will not scale. It's not a trivial or an easy way to configure these or images or different instances that use these images to deliver monitoring in different ways. So the alternative way is to use the Cloud Init service provided by the OpenStack or by the cloud managers. Cloud Init are like Python scripts and utilities that allows the developer to install everything that he might need. it or the cloud init manage early installation of instantiation of virtual machine instances, and the images have it pre-installed. Then, while booting the image, the installation and execution of the XIFI or Puppet recipes are done through the cloud init. And as you see in this picture, that virtual machines connect to the Segeta component in order to know the recipes that should be installed on the machine. Segeta gets this information or is informed by Pegasus about which software should be installed in which machine instance. Of course, not only for the post-processing or post-installation, but also to have full control of what the developer needs to install on each virtual machine. Pegasus offers an automatic provisioning of virtual private networks between different nodes to link the application resources. Of course, in case the template is deployed in multiple nodes. So again here, Pegasus includes multiple stages: deployment design and deployment execution, orchestration, creating multiple virtual machines, and the software inside, which means the GEs, which GEs in which virtual machines, because some GEs could be deployed multiple ones in one virtual machine, or a GE needs multiple virtual machines. It depends, and the configuration of monitoring information, real-time information about the available GEs, etc. So the second main component, called deployment and configuration adapter. This component provides real information about the available GE instances in the Cloud Federation that are deployed either as software as a service or platform as a service models. So the user, for instance, now the resource catalog, gets information from the deployment and configuration adapter, called DCA, about all running GEs that belong to a developer or to all developers, or what are available without being used. Of course, following a set of policies that a developer cannot see which GEs belongs to other developer, etc. So it exposes a RESTful API that can be used either by the developer or by any other tools or components like the resource catalog. So in order to get information about the available GEs deployed in different nodes, it's not a trivial task. There is, of course, some challenges. We will discuss here just two of the main ones. The first one is a technical challenge, or we need a technical solution that allows the DCA component to access each individual infrastructure. We expect some potential strict access policies applied by infrastructure owners, so that some not willing to provide administrative privilege to external parties or components. For this to be overcome, we provided a software component that can be deployed in the infrastructure, which is able to collect respective information through the OpenStack Nova and Glance components. This script is configured, edited, customized by the administrator before installing it, of course, on the controller of the infrastructure, the DCRM component, and thus allowing infrastructure owners to preserve access privileges. So the second challenge, which is FIWARE Lab specific issue, so related to unambiguous identification of the deployment of a specific GEs in several nodes. So we have a question on how one will be able to identify that the same GE is deployed in these two nodes, if we have two, for instance, in previous example. So how to differentiate between these two GEs if they are from the same instance, maybe used by the same or different developers. So the first option is to use the name of the virtual machine that the user gave during the deployment. Of course, this option is not applicable because the user or the developer is free to use any name, which I can maybe name my GE instance with the same name of the GE. Let's say context broker GE, I can call it context broker. Another guy call it context broker, which at the end we will not have the same identifier. Another option is to use the image reference identifier, which is provided in the OpenStack, or provided by OpenCloud OpenStack glance module. But this is also not applicable due to the fact that these modules might use their own image identification numbering schemas, which will have different representation. In FIWARE Lab, we decided to use a new mechanism to provide identifiers. We call it NID. This is given by the Pegasus during the deployment of the GEs, can use the metadata service offered by the OpenStack and insert specific values. We call it, as I said, NID, in the glance metadata in order to provide uniquely and unambiguously allows for having unique GE identifications across the federation. So the last component we have is the federation monitoring. The federation monitoring is, let's say, the operational layer which is in charge of storing and publishing the unified dataset to the users through well-defined API. So below to the federation monitoring layer, we have another layer called infrastructure monitoring middleware, which is a cross-domain adaptation mechanism on top of the local monitoring systems. That means each node can deploy whatever monitoring solutions inside, but through adaptation mechanisms, through some adapters, provide the data in a unified manner to the federation. Following or to provide a unified format, we use the NGSI adapter, which is one of the technologies that provide the data in a context format, provided by Open Alliance. As we see, the federation monitoring components consist of multiple components or subcomponents. They are depicted in this figure. The first one is the context broker that receives the data from the infrastructure monitoring middleware in a context format, and then store the data in Hadoop component that provides scalable, reliable, and distributed data processing and storage mechanisms. And from Hadoop, the data in the slave node are pushed to the Hadoop instance at the master node. And of course, the Hadoop deployed in the master node is allowed to perform operations with the relational database. Of course, after elaborating the data and doing some aggregation, for instance, to provide the average value of a specific metric within last 1 hour, because as we know, we will collect large number of data. And this is the idea behind having Hadoop, in order to elaborate the data and aggregate only the useful data. Of course, relational database exists only on master node that stores the already processed data set and provide it in an easy and faster manner to the server, Federation Monitoring API server that provide the data through RESTful API to the user. Again, here we see the individual components of the Federation Monitoring. The context broker, as I said, notify the monitoring data as NGSI, next generation service interface context format into the context broker that handles the data set and update the metrics into Hadoop that performs some aggregation or aggregating operations to the received data and store them then in the relational database that provide the data then to the user through the API. So shortly I will talk here about how to manage resources in a multi-tier fashion. For instance, now if an application willing to offer a weather service by allowing users to check weather conditions or automatically informed about sudden weather change via web service, websites, whatever. So the weather information should be collected from different sensors. That means that the developer will need to have some sensing capabilities. He selects, of course, which nodes that can offer these capabilities, and he needs to have context broker to that collect the data or get the data provided to him and publish the data in a context format manner to the complex event processing GE. This is just an example how this would be deployed. The CEP GE is responsible to process the information from sensors and create events following a customized threshold. And then the data are displayed via the WireCloud GE or utilizing the WireCloud GE. Now we'll need 3 GEs and some sensors. But due to some regulatory reasons, the Pegasus might need to deploy these 3 GEs in different nodes. Let's say regulatory reasons, some countries don't want to publish data to outside the country. So in this case, we need to have, let's say, the context broker and the complex event processing GEs in that country. while to display the information somewhere else, the FIWARE cloud can be deployed in another node. It's no problem. So the DCA allows a user then to query its API, the API of the DCA, and list and check his own deployed virtual machines and GEs. There's some examples in some papers. If you are interested, I can show you how it works, or in the wiki description of the DCA. And of course, they can, through the monitoring APIs, get monitoring information about the deployed GEs, their performance status, and the virtual machine performance, CPU load, memory, etc. Of course, in order to get monitoring information, you need to request data per ID. That means, as I said, the Pegasus provides the net or NID to have a unique IDs. These are used by the user to query the monitoring systems to get monitoring information about these. So, to conclude, in this webinar, I just presented the FIWARE Lab Solutions for seamless deployment of services and applications of the developers across the Federation that are supposed to be deployed in an easy and automated manner, orchestrated manner. Solution for monitoring these resources and services and providing aggregated data through a common and unified manner. Information related to the availability of resources and services, which are represented through the DCA, and or we call this real data information, real-time information. And the other information is about the usage and performance of the deployed virtual machines, including as well physical information or information about physical machines if requested. These solutions are implemented and deployed in FIWARE Lab in a federation of 17 infrastructures deployed across Europe. In order to use or to interact or to test or to start developing in FIWARE Lab, you will need to have an account, register, and start enjoying the federation offers through the cloud portal. So how developers can use and start deploy, interact, create their applications, this will be presented in the upcoming webinar this Wednesday, 25th of February, by my colleague Brent Bocho from Fraunhofer Institute. So thank you for your listening. I hope that I was clear somehow, and I'm ready for having your questions. If you have any question, just raise your hand and I will allow you, unmute you. Yes. So, Kantong, go ahead.
Yes. Could you please, first, could you hear me?
Yes, I hear.
Yeah, could you please put the IT box in the context of what you discussed today?
IT box is a component that is used by the infrastructure provider for deployment of the software and components required for the operation of the node. That means, as I said, the slave node includes, or even the master node includes operation layer software, including the monitoring and security and OpenStack hosting functionalities. 3 main subsystems. All these components are deployed with the help of the IT box. Now, if you run the IT box, all these components I can show you in this figure here. You see the lower part the lower part, you see this? All these components in the lower part of the architecture are deployed through the IT box. In this webinar, I just discussed 3 components, which are DCA and Pegasus on the master node, are not deployed by the IT box. Federation monitoring components in the slave node, they are deployed through the IT box. The presentation here is just to show how the developer can, how we facilitate the deployment of the developer needs or applications across the federation. With the help of Pegasus, we can deploy applications across domains in an automated way. We don't need to bother the developers to do the configuration and the deployment and the setup and where and how. And the DCA helps the developer to get information about the currently available GEs that I can use, or my own already deployed GEs or services. Imagine that I have multiple applications and I don't want to redeploy another GE instance. I can just use one of those that I have already deployed for another application. I can use it for my new application. And the monitoring data that are of interest of developers. So, is it clear?
Yes, I'm still trying to get an overview. Right now, most of us are using the FIWARE Labs to learn context broker, to learn mesh up, to learn different GE. I wonder, what is interesting about IT Box is it frees us from this FIWARE Labs, where we could install on our own computer or virtual machine for testing. Yeah?
If I may stop you here, are you an infrastructure owner or you are a developer?
I think what we're trying to do is we're trying to learn both.
Okay, if you are an infrastructure owner, the IT box is the first and the very important component for you to start with. If you are a developer, you don't need to understand the IT box. Yes, go ahead.
Okay. Yeah, I guess the purpose of the infrastructure is that if you have proprietary data, which you need to have protection, you definitely need to have this FIOps configuration.
Of course,
right?
of course, of course.
Yes. So at the same time, we need to work with our own data within this FIOps. So that's why it's a combination of developer and infrastructure.
Yeah, I see. If I could talk about all these components, we will need more webinars. I mean, I didn't talk about the FIOps in this webinar, though. The FIOps is, let's say, the software that's needed by the infrastructure owners mainly for having the whole setup and deployment of what we have in FIWARE Lab. So I just here try to give an overview for our solution for the cloud federation management from the developer's viewpoint. So,
one question within this slave node, is it possible to set up mesh up too?
Mesh up tools.
Mesh up, yes. I mean the wire cloud in order to work with the different GE.
Let's see. Okay, we have in the first stage to understand that we have an architecture that comprises a set of components. These are required to have the management and operation layers or software of the management and operation software. So these are implemented, or they are implemented through GEs or new components developed within XIFI. Now, there are other GEs that are provided as a service for developers, like via cloud. So, via cloud is part of, I don't know whether it's part of the XIFI monitoring functionality or not, but I don't think so, because the federation monitoring, yeah, it's, I mean, wire cloud is not part of the architecture of the FIWARE Lab Federation architecture. But it's
the question I ask is, I mean, you're using the IT box to install the necessary component. I just want, and you know, GE and context broker. I just wonder whether IT box can also, you know, where can I find the list of things that can be installed with IT box, and also whether IT box can help to install things like wire cloud or mesh.
No, it will not help to do this, because it's a standalone box that you execute, and all the required and the mandatory softwares in the slave nodes is deployed. Only the main and the mandatory components. That means you cannot configure it, or maybe you can contact the developers, which is CreateNet, and ask them to have extra release for you, which I don't think that they will do. Or you can learn how this is implemented, and you can change it, but it's out of the scope of the purpose of the operation software of the slave nodes of FIWARE Lab Federation. So it's a standalone box that you execute, and that's it. But if you want to extend it, just talk to CreateNet guys, and they can maybe help you here. But
okay.
Yeah.
Okay, the last feedback is, I think it's a very good idea to organize this series of webinars, and this is really speed up the process of learning this whole FIWARE Lab.
Okay, thank you.
And FIWARE technology, sorry.
Yeah. So we will have this Wednesday another webinar, so you can, I think you are aware of this.
Is this a webinar also on the FIWARE website? Because I thought there's only one when I saw this today.
Yes. And we will provide this webinar as a video later on, and we will have a series of webinars. So if there is another question by others, please. No further questions? Oh, there is in the chat, I think, a question which is very long, I would say. Yeah, Mark.
Hi, thanks. Hi. Yeah, it's Mark here, thanks. Yeah, okay. Just to reiterate and answer maybe the last question, that we've had a number of webinars already covering some topics that would provide additional information to people. All of those webinars are recorded, and they're available on our training portal. As well as that, there the webinars, there are a number of physical presentations that were video recorded, and the PowerPoint presentations are available. So that there is actually a wealth of information already available on our training portal, including a how-to guide for the IT box, which I know was a question that was asked there in terms of the context of the IT box. We've divided up our XIFI, our FIWARE Ops training portal, specifically towards, there's a section for infrastructure owners, there's a section there for FIWARE Ops developers, and then there's another section for FIWARE accelerators and startups, SMEs and startups. So there will be an email sent to all of the participants after this webinar is finished. It's a questionnaire, but it also includes all of the links, including the link to our training portal. I don't know whether, Yaya, you can put the link up. I've sent the link in the chat screen to the infrastructure It's the edufireware.org. I don't know whether you can put that up on the screen.
Which one again?
I put the link up in the chat window. It's to the specific section on our FIWARE Ops training portal where that person who asked the question about IT Box. There's a presentation there on IT Box. I don't know whether you can see that in the chat window.
I have a problem now with opening the chat window. I don't know why.
Okay.
And
all right. Well, just for all the people that are listening, if you do want more information, we do have a training portal where, as I said, there's a wealth of information available. There's also a question and answer section. We can redirect you if you've got specific questions in real time. There's a link on the training portal, Stack Overflow. There's a dedicated section in Stack Overflow to anybody that has a FIWARE-related question. So if you can't find information on the training portal, you can ask questions directly from Stack Overflow. The page also includes links to our help desk if you've got other questions. So I hope that if you do have any further questions in relation to either the presentation from Yaya, and thank you very much, Yaya, for your presentation. It's very, very clear. But if you do have any other questions that are maybe outside of the scope of this particular presentation, as Yaya said, there's another webinar on this Wednesday, and then we have recorded a lot of information, as I said, and you can still get help from any of the FIWARE or FIWARE Ops or FIWARE Lab team through the number of portals. Okay, that's me.
Thank you, Mark. Ka Tong, do you still need to speak, right?
Yes, I went to the FIWARE main page and I look at the events. Today's webinar is not listed there, and I'm trying to look at the 23rd.
Yeah, FIWARE.org is not the correct place, I think, where to find the webinars. It's the XIFI.org. There you can find, because these webinars are organized by XIFI project, not by FIWARE project. Okay. You know, XIFI is just a project that built the federation for FI-PPP program, utilizing, of course, the FIWARE technologies. And we will have a new project called FI-Core that continue the work of XIFI. But at the end, we have now just one instance of this federation called FIWARE Lab. And you can find the series of webinars through XIFI project website, which is xifi.org.
So XIFI is phase 3, yeah?
No, phase 2. And then it finished in 1 month, almost end of March this year. And then we will have just the third phase, the accelerators and the FI-Core, etc.
Yeah, just a feedback. I mean, I really see the potential of this whole FI-PPP, private public partnership, and the challenge really for people like me, new, is to try to see how get an overview how the different things get together. You know, it's just whenever you mention training place, the question is where and how this is organized in a whole umbrella. I mean, ideally there should be like a phase 1, phase 2, phase 3, how everything evolution or how everything come together, and where do you need to go for this and that, and whether there's a redundancy, how everything fits together. This is only possible when we can have continue to have webinar, to have people like you to give us up-to-date overview of how everything come together. Because if we go to the existing webinar, we learn something, but we'll never get the overview. The overview only get from pieces from you a little bit here, another person a little bit there, in order to piece together the whole potential added value of this whole FI-PPP.
Okay, I give my 2 cents here. So in the first phase, we had the FIWARE project that has delivered a lot of future internet technologies refer to with generic enablers in different areas, let's say in a cloud area and data delivery, Internet of Things, and in networking areas, security, etc. So it's around 80 generic enablers have been developed. So in phase 2, with the help of XIFI project, we thought about creating federated cloud-based infrastructures across Europe that are built for open innovations, for future internet experimentations. These infrastructures are mainly based on cloud or built by cloud hosting technologies in order to provide different services in a cloud or through cloud service or in the modality of cloud computing like PaaS and SaaS for the developers. These PaaS and SaaS, we provide the cloud resources in order to host technologies or services that are requested by developers. And these technologies and services are indifferent. Again, we utilize the rest. Okay, sorry. The federation is built by some of the GEs provided by the FIWARE from the cloud domains and the security domains, monitoring domains, in order to build the federation architecture. Now, there is more other GEs. Enablers for different technologies are provided as service for users that can be requested through the cloud portal of the FIWARE Lab Federation. So some nodes, some infrastructures provide in advance to, or in addition to the generic enablers or these kind of future internet services, we call them, of course, generic enablers. They provide, in addition to these, some future internet capabilities or infrastructure capabilities like sensing, sensors, like 4G, 5G, etc. Facilities. These can be used by some services or by some GEs in different fields, in IoT field, to have entire ecosystem in IoT for e-health domains that might use cloud GEs, might use IoT clouds, might use networking GEs, etc. So this is a huge and entire ecosystem. Now, in phase 3, there is so-called accelerators that helps startups and developers, SMEs, to understand, to utilize the offers of the FIWARE. Let's say FIWARE Lab, FIWARE Technologies, FI-PPP program offering, whatever. So this is short overview.
Yes, I thank you for that, and I really think what you have done today is very important. Someone to just come and have this two-way interaction, because there are a lot of webinar, there are a lot of e-learning. I mean, you can do this, but you are getting the fragmented view of this potentially huge potential advantage, you know, of this technology. So I really appreciate what you've done here is to organize a webinar for people like us to have a dialogue, to refine our understanding of this complexity.
Yeah, thank you so much. Actually, maybe it could have been better if we started organizing the webinar in a different way by introducing the main concept or the idea in a different way. So we start to talk about the FIWARE and the XIFI and the federation and then the offering and the sustainability considerations, whatever, and then we discuss the offers and how users can interact, etc. So you are right, yeah, but maybe we will improve.
Yeah, I mean, I'm making use of the opportunity here to give my feedback. I mean, what I understand, the future direction of FIWARE is something called FIWARE Mundus, yeah, again, to spread this technology like the phase 3, not only to the startup who are participating to accelerator, but also to other people who are not part of this accelerator program, did not get in, but would like to know more about FIWARE. So and this and now with this new constraint of infrastructure that is the limiting the number of people who can actually testing the technology in the cloud service, because it's just overloaded. So what IT Box as a one-stop solution for installing either to a computer or the virtual box, yeah, like a virtual box, yeah, it's a very good way to help people to continue to play around, to test, to do by learning.
Yes. Thank you for your feedback. Yes, I ask if there is further questions. If not, so maybe we can finish this webinar, because we are beyond the schedule 30 minutes. So thank you very much for your participating and feedback, and let's see you in the upcoming webinar on Wednesday. Thank you so much, and bye-bye.